So let's go ahead and do an example where we have to use that inverse. So we're going to be trying to compute L inverse of 2s plus 5 over s minus 3 squared. And this is using that property that L inverse of capital F of s minus a is going to be e to at times f of t. And so when I look at this problem, I see an s minus 3. So I know that that's the s minus a I'm going to be working with, but I don't see it up top. So kind of our first step is to rearrange the thing we're given, which I just copied down again, so that it looks like some capital F entirely in terms of s minus 3. So this is going to be, again, one of those like big, long algebraic manipulation steps. And I've already got s minus 3 squared in the denominator, so that's nice. But then up top, I'm not seeing an s minus 3. So I'm going to go ahead and say, okay, it'd be perfect if it looked like this. And that's the same as 2s minus 6. But instead, I had 2s plus 5. So if I have 2s minus 6, I'm going to have to add 11 to it in order to reach 2s plus 5. So minus 6 plus 11 balances out to 5, which is what I started with. So these are the same thing. I've just written it now in a more convenient way. Then that's 2 times s minus 3 over s minus 3 squared plus 11 over s minus 3 squared. Splitting up that numerator, which is something I'm allowed to do, even if I can never split up the denominator. And then I'm going to go ahead and cancel out on top and bottom one of those s minus 3. So I just have 2 over s minus 3 from that first term. And then the second one is going to stay the same. And now, everywhere that I see s, it's actually an s minus 3. So I've accomplished my goal of making it look like f a function of s minus 3, which means I can go ahead and take my inverse now. So L inverse of that 2s plus 5 over s minus 3 squared that I was given is the same as L inverse of 2 over s minus 3 plus 11 over s minus 3 squared. And then I'll apply linearity, so this looks like things that I know the inverse Laplace of. So 1 over s minus 3 by itself. And then I'm going to bring my 11 out front and look at L inverse of 1 over s minus 3 squared. And then I need to take inverse Laplace of both these terms. This one's easy, it's my exponential. We've used it very recently. But the second one is a bit more complicated. So it kind of looks like L inverse of 1 over s squared, except s turned into s minus 3, which is completely fine. So then I need to know that that's L inverse of 1 factorial over s to the 1 plus 1, which takes me to the function t to power 1. So t is going to be my little f of t here. So what I get out of this is going to be 2L inverse of 1 over s minus 3 plus 11 L inverse of 1 factorial over s minus 3 squared. And since 1 factorial is 1, I don't have to do anything special here, but if I was introducing a number, I would divide it down here. In this case, I'm looking at, for the first one, that's an exponential with a equals 3. And for this one right here, this is my capital F of s minus 3, where f is 1 over s squared, and a is 3. So then taking those inverses, I've got 2e to 3t for my first one, that exponential, that was the easier of the two, plus 11, and I'm going to need e to at, so I'll again see an e to 3t from this part right here, times f of t, and I set up above that our f of t was t. So then I just multiply by t. And at this point we've finished taking the inverse. So the previous video with this one gives us everything we need to go forward and backward in Laplace. So the next example we're going to do is going to be an initial value problem that uses both those things. I will go ahead and make that the next video by itself, just in case it runs a little bit long. I can't remember if there's partial fraction decomposition or not, so I'll see you in that video.